Section 10.4 on hyperbolas. So a hyperbola is the set of all points x, y in a plane where the difference of whose distances from two distinct points or foci is a positive constant. So if you're looking at these equations, the standard equation of a hyperbola looks very similar to the equation of an ellipse or a circle. One minor difference, the minus in the middle. And notice that for the horizontal hyperbola, the x squared is positive minus the y squared. For the vertical hyperbola, it's y squared is positive minus the x squared. Okay, for hyperbolas, we're still going to have focus points. We're going to have vertices. We're going to have asymptotes that help guide the hyperbolas. So the asymptotes of a hyperbola, the equations are two different equations, one for horizontal, one for vertical. Y equals k plus or minus b over a times x minus h, or y equals k plus or minus a over b times x minus h. So I have a hard time remembering which one is b over a or a over b, so I'm going to show you a trick that I use to look at the slope of the line after we graph it, and then we can just write down the slope instead of remembering b over a or a over b. And then last thing we're going to look at is the equation of conics in general form and being able to determine which conic it is. So when it's all expanded out, we're looking at the ax squared plus cy squared terms. We're looking at the a and c, the variables in front of, or the coefficients in front of x squared and y squared. If those two coefficients multiply together and equal 0, then our conic is a parabola. And one way that I look at it is if there's only one x squared or one y squared and not both x squared and y squared, then I know it's a parabola. If the coefficients of x squared and y squared are the same, doesn't matter what those numbers are, if they're exactly the same, then the conic is a circle. If both of the terms in front of x squared and y squared are different numbers, but they are both positive or both negative, then it will be an ellipse. If those two numbers are different numbers, or they could be the same, but one is positive and one is negative, then that will make our conic a hyperbola. So example 1 wants us to find the center, vertices, foci, and asymptotes. So we're going to start with this the same way we graph ellipses and circles. There's going to be a few differences after we put those initial points on. So we're going to start with the center, and I know that this hyperbola is going to open up and down because y squared is first. So it opens up and down because y squared is positive. And then my center is 0, 0. Same as with ellipses, it's the number on top with x squared and y squared. So I start at my center, 0, 0. Take the square root of the number underneath y, and that tells me how many to go up and down. So I'm going to go 5 points up and down from the center. Take the square root of the number underneath x, and that tells me how far to go left and right. So square root of 81 is 9, so I go 9 spaces left and right. Now, if this was an ellipse, we would connect the dots. This is a hyperbola. So we're going to use these 4 points to create a rectangle. This rectangle will be the guide to draw in our asymptotes, which is then a guide to draw our hyperbola. So after you've drawn your rectangle, you're going to connect the diagonals and draw those in. These are the asymptotes of our hyperbola. They're the guides that tell me how wide or skinny to make my parabolas when I draw them on two sides. So since this opens up and down, I start at those top and bottom points and I draw in a parabola that goes as wide as my asymptotes. It gets really close to it but never touches or crosses. So then I can write and find the location of my focus points by using c squared equals a squared plus b squared this time. For ellipses we subtracted, for hyperbolas we're going to add. So c squared equals 106. So the square root of 106 spaces away from the center is where my focus points are. Well, the square root of 106 is a little over 10, so I would go 10 spaces from the center in both directions, up and down, since it has to be inside the hyperbolas, and that will be the location of my focus points. So at 0, comma, square root 106, and 0, comma, negative square root 106. My vertices are the 2 points that touch on the hyperbola from my rectangle. So 0, 5 and 0, negative 5. I don't need the 2 orange points that went left and right for vertices. I only use those to create my rectangle. Now for the asymptotes. The asymptotes are an equation that's y equals k plus or minus the slope of the line times x minus h. So in this case, our k is 0 and our h is 0. So our equation is going to be y equals plus or minus 5 over 9x. And I know it's 5 over 9 because I look at the slope of my line. I can start at the center of my rectangle and go up 5 spaces and over 9 spaces to the corner of my rectangle. So I know the slope of the line is 5 over 9. Same thing on example 2. We're going to find the center, vertices, focus points, asymptotes, and then graph. So for this hyperbola, I know that it opens left and right because x squared is first and positive. My center is going to be negative 3, 2. I'm going to start by taking the square root of the number underneath x, and I know to go that many spaces left and right. So I'm going to go 4 spaces left and right. Take the square root of 25, and I'll go that many spaces up and down, so 5 spaces up and down. And we're not drawing an ellipse, we're drawing in a rectangle that will be a guide for our asymptotes. So once your rectangle is drawn, you're going to draw in the diagonals of the rectangle, which are the equations for the asymptotes, or the lines for the asymptotes. Since this one opens left and right, I'm going to draw in my hyperbolas going left and right. They get really close to the asymptotes but never touch or cross. Our vertices this time are the 2 points on the left and right, so that's going to be negative 2, 7 and 1, 2. Negative 7, 2 and 1, 2. Okay, then to find the focus points, c squared equals 25 plus 16. So c equals the square root of 41. The square root of 41 is going to be a little bit more than 6. So I go a little past 6 in both directions, whichever way my hyperbola opens. So my focus points are from the center, left and right, the square root of 41. So I'm going to add and subtract the square root of 41 to the x-coordinate of my center. Negative 3 plus square root 41, comma 2, and negative 3 minus square root 41, comma 2. Now for my asymptotes. Asymptotes are y equals k, our k is 2, plus or minus the slope of the line, which is 5 over 4, times x minus h. So 2 plus or minus 5 over 4 times x plus 3. So now in example 3, our equation is not in standard form, it's in general form. So I'm going to use the same steps that I did for ellipses to get this in standard form. So I'm going to start by grouping the x's, grouping the y's, and constant moves to the other side. So 9x squared minus 36x minus y squared minus 6y equals negative 18. I look at my x's and I'm going to factor out whatever number they have in common. So that's going to be 9 times x squared minus 4x, and I'm going to leave a space because I know I have to complete the square. Same thing for the y's. For the y's, I'm going to factor out a negative 1. So that will leave me with y squared plus 6y, and then leave a space, equals negative 18. So So to complete the square, I'm going to take -4 divided by 2 and square it. That's going to be plus 4. I didn't just add 4 to this equation, I added 9 times 4, so I need to add 36 to the other side. For the y's, 6 divided by 2 squared will be plus 9, but I really added -1 times 9, which is -9. So now I can write these perfect square trinomials as a perfect square. So this is going to be 9 times something all squared. This is going to be x minus 2 all squared. Minus something all squared. This will be y plus 3 all squared. On the right, when I add all these together, will equal 9. I need it to equal 1 on the right-hand side, so I divide everything by 9. So when I simplify x minus 2 all squared over 1 minus y plus 3 all squared over 9 equals 1. Okay, so now I have everything I need to graph my hyperbola. So I know that this hyperbola opens left and right because x squared is first. The center will be at 2, -3. The square root of 1, I'm going to go left and right, so that's 1 space left and right. The square root of 9 up and down, so 3 spaces up and down. And we're drawing in a rectangle here, and then we will draw in our asymptotes. Since this opens left and right, I'm going to draw in my hyperbolas left and right. The vertices are at 1, -3 and 3, -3. To find my focus points, c squared equals 1 plus 9, or c squared equals 10, so then c equals the square root of 10. The square root of 10 is just a little bit more than 3, so we're going to go a little over 3 spaces from the center, left and right, for my focus points. So since those were left and right, then I need to add and subtract the square root of 10 to my center. So 2 plus square root 10 comma -3 and 2 minus square root 10 comma -3. For my asymptotes, y equals, I start with my k, which is -3, plus or minus, the slope of the line is up 3 over 1, so that's just 3, times x minus 2. Okay, the last example, we're going to determine the name for each conic given the general equation. So on part A here, I have this equation that has 2y squared plus 2x plus 2y plus 1 equals 0. I notice that there's only one squared term in this equation. When there's only one squared term, then it has to be a parabola. If you think about the equation of a parabola, there's either a y squared or an x squared, but there's never both. This second equation, I've got 4y squared minus 2x squared, and then a whole bunch of other stuff. I really only need to look at the y squared and x squared to determine what type of conic it is. Well, I see I have two squared terms. One of them is a positive and one is negative. So since I have opposite signs with the squared terms, I know this is a hyperbola. C, I've got x squared plus y squared minus 25 equals 0. So I have two squared terms that have the same sign and the same coefficient. So that will make this a circle. Same sign and coefficient makes it a circle. And then last, 4x squared plus 9y squared minus 36. I have two squared terms with the same sign, but they're different numbers. Notice the 4 and 9. So that will make this an ellipse.